Hello, everybody, and morning, and welcome to re:Invent. Imagine that you're busy preparing for a launch, and it could be a feature, it could be a product, some most awaited launches by your customers. You have all your marketing lined up, and you have a wonderful audience like this in a room waiting to hear all about that launch. And then you face an issue just before launch. A lot of this session is actually going to focus around getting you operationally ready before you launch, while you're launching, and after you're live. My name is Surbi Dangi, and I'm a product management leader in Amazon CloudWatch. And accompanying me on stage today will be my colleague, Rodrigue Kofi, who's a resident observability expert and a senior specialized solutions architect. In today's agenda, we're going to cover what it means to do observability and why it's important. We'll also talk about what capabilities you can leverage, as well as do a quick demo to really show you how observability works in action. And then we'll leave some time for questions, but worry not if we don't have time. Both Rodrigue and I will be hanging around here for quite a while, so please don't be shy to come say hello. So let's jump right in. We're going to take the example of a fictitious example corp startup, and this startup starts small in its first releases. It's a pretty simple technical architecture. You have all your backend, your database, your front end, all in a single code base. It's a pretty monolithic architecture, maybe a couple of servers. And as usage grows, very soon it starts evolving, and the needs from the architecture evolve as well. Now the architecture needs to be scalable, it needs to have redundancies, you need to be able to sort of deploy features quickly, and oftentimes this is okay for a very long time. You can actually have this architecture and continue serving your users. But as the business evolves even further, you'll now see a pretty complex application with a distributed application that you've migrated to a pretty complex application of hundreds of components. You have message queues, you've now become a NoSQL shop, and then each of your developers want to code in a language of their choice. So there's a lot of language proliferation as well. And then at some point, an architect also tells you, hey, we need to now also further add message brokers. And so you end up with a bunch of message brokers to this architecture to create isolation. And this is a classic example of when threading the needle through a single user request that went wrong, that had an anomaly, a latency, and availability issue, becomes challenging. It's really sifting a needle through a haystack. Besides, now you have several teams that have expertise in their own systems and areas, and it often requires a lot of back and forth and collaboration. The challenge is really also true for event-driven development, where your issues are not immediately relevant, or your issues are not apparent right away. And so they may hit your user after a point in time. Well, I'm preaching to the choir here. This is what observability helps you do. It helps you ask questions about your architecture, about your systems, and then helps you achieve operational readiness. I'm preaching to the choir here, but yes, everyone is familiar potentially with metrics, logs, and traces, and that really forms the foundational observability, but really it's a lot more than that as well. So think of continuous profiling, think of crash dumps, think of real user monitoring, Think of monitoring synthetically. The list goes on. And the good news is you don't need all of it right away. You can progressively dial your observability as your needs evolve into the nature of your application. So let me show you how some customers implement observability today. A lot of customers tell us that they need prescriptive guidance on how to think about observability in their strategy. And they struggle with a lot of outdated tooling. They also try to sort of figure out their strategy to centralize their observability needs and get more efficient with costs with observability. To this, we recently launched the AWS Observability Maturity Model, and this helps customers sort of understand how to get more and more mature with observability. And of course, everyone wants to be at the most ideal stage 4, and this is really when technologies like generative AI, as well as machine learning, really work for you and help you do automatic root cause remediation. But it's important to recognize that the foundations are extremely critical. The foundations are really about making sure you have the right telemetry pipeline set up with the right metrics, logs, and traces being collected. And this forms the basics for you to be able to do a lot of analysis and insights. And then finally, all of this helps you then further build on top of it and get you correlations, get you richer insights, deeper analytics capabilities, and that is where the power of application performance monitoring, or APM, lies. In a nutshell, this is what motivates us to talk about observability. It really helps you improve your end-user performance. It helps you understand your application health, also helps you reduce costs, and then improve overall the performance and availability. In this session, we're going to talk about Amazon CloudWatch and AWS X-Ray and how we power observability using these tools in AWS. Now, at the very fundamental, the CloudWatch agent helps you instrument and collect this foundational telemetry that we just talked about, which is metrics, logs, and traces. And on top of it, there are several other capabilities in Amazon CloudWatch that help you visualize this telemetry better. And visualizing is really important. Things like a regular operational dashboard that your team can use as a go-to dashboard. We also have capabilities like cross-account observability, where you can actually monitor from a single monitoring account and stitch this end-to-end picture together. On top of it, you layer on insights and analysis, and there are several capabilities that go much deeper into containerized applications, serverless applications. You have tooling that helps you go deeper into logs, and then search logs as well. And then the last step of the stack is really, how do you really understand what your end users, your customers, are facing? And this is done through several other capabilities like synthetics, real user monitoring, and internet monitoring. And last but not the least, if you really want to bring all this telemetry together into a single pane of view, there are several partners and integrations that are powered in Amazon CloudWatch. Now, this may look like a lot, but all of this can be progressively turned on, and it's really a journey. So not to get overwhelmed. Now, you might think I'm biased, and I very well may be. And so it's always better to hear directly from what customers use, how customers use Amazon CloudWatch for observability. Mapbox is a provider of custom online maps for web apps, websites, and applications. And today they use Amazon CloudWatch to really get their operational readiness. They also use this to consolidate observability tools, get operational efficiencies, give their operators one tool, and reduce the learning curve. Booking.com is one of the world's largest travel agency websites, and they have been using Amazon CloudWatch Real User Monitoring, RUM, to monitor their end users' core web vital metrics. And this is really important and one of the first leading indicators of how their applications are doing and react to issues very, very quickly. With this, now that you've had a glimpse of how to think about the observability maturity model, let's talk about how we can make Example Corp more observability confident. So let's look at sort of the 5 key stages that we're going to talk about today. And this is how we think of observability. First, you want to set up your instrumentation. And the reason instrumentation is really, really important is because if you don't have data, you're really going to be running blind. You're not going to be able to analyze anything. And this is an area where we're going to start with deep diving into logs. And as you know, there are different kinds of logs. You can have application logs, but then there are also system logs, audit logs, security logs, and you probably want to be logging at all levels. In addition, logs often contain PII data. They contain all kinds of unstructured data, and in the demo, as well as with a few other capabilities, we're going to look at how to sift through all that data and how to make sense of it all. Now, when you send your data, you have all kinds of data coming from different compute platforms and sources, things like EKS, the Kubernetes service, ECS, your serverless environments. And imagine trying to do a dash tail command all on logs from all of these platforms at the same time, at scale, and on streaming data. Amazon CloudWatch Logs Livetail, which is a new capability that was just launched, helps you sift through all of this data all in real time just through the Amazon CloudWatch console. And you can see in the screenshot, it's a highlight UI that really makes it easy for you to spot what you're looking for, and we're going to show you this in action in a little bit. Now, once you have these many logs, one of the first things you're going to start thinking about is, how do I optimize costs? And not all logs are always needed right then. Sometimes you don't need to use them right away. And so, but then you still need to collect them and store them somewhere so that you can use them when you need them. Towards this, we've launched Amazon CloudWatch Infrequent Access. It's a new type of log class that helps you do historical querying, ad hoc querying, and it's a really powerful tool to help with costs. Now you're telling me, well, you must be thinking, well, now I need to know how to query these logs that I have collected, and there are quite a lot of them, right? And so another exciting capability that we've just launched in preview is Amazon CloudWatch Natural Language Query Generation. So today, in the CloudWatch console, you can ask in plain natural language in English the output you're trying to get from a query. And then this query generating capability will author this query. It's interactive. You can save these queries. You can build on top of them. And powered by generative AI technology, this querying capability really simplifies the way you start interacting with logs. Now, you must be thinking, well, you can live tail the data. You can classify certain logs as your infrequent access logs. You can also assist me in writing queries, but what if you didn't have to query at all? One of my favorite capabilities that we also launched this week is Amazon CloudWatch Logs Anomaly Detection. And what this does is really surfaces the most important patterns that it's finding in logs. What this does is, and one of the interesting capabilities here is the ability to compare. And this comparison between the before and after state really helps you understand not just anomalies, patterns, but also the change that is being observed in behavior. So there is, of course, additional capabilities that exist in CloudWatch Logs, and we're going to see it in the demo in a little bit. But I want to move on to the second most important foundational capability, which is metrics. And defining the right metrics is extremely important to your observability strategy. Think of defining your metrics aligned to key business operations. And what that means is make sure, for example, in example corp, do your metrics denote your cost per transaction, or do your metrics denote customer sentiment? So really tie it back to what your business is trying to do. And that helps you design a really good dashboard at the end. That's really the end state that you want to be looking at every single day. In addition, when you don't have the possibility to go back in time in logs, you can also extract metrics from logs and then leverage a bunch of filters with patterns and regex operations in order to sift through all of this historical data. And don't forget, several AWS services also have free metrics that are published for you. And then if you want to go deeper, you can actually enable several insights capabilities to really get further detailed visibility. Towards that, this recent launch helps you understand how to get deeper visibility with detailed monitoring for EKS in Amazon CloudWatch Contributor Insights. And what we've really done is simplified and given you a really easy way to enable this with the CloudWatch add-on directly from the Amazon EKS console when you create a cluster. Now, last but not the least, I don't want to forget traces. And traces are really key to be able to navigate user transactions and follow the requests end-to-end when you're really diagnosing an issue. And to think about traces as something you can turn on with even a low 5% sample and then progressively dial up based on your needs. You could even modulate it based on your requirements. And the idea is to get at least some examples of how the request behaved when it came in. There are many cases where you can also leverage automatic instrumentation and get immediate visibility. So AWS X-Ray will generate the trace map automatically for you. It's a really nice visual picture that helps you really zone in into the problem area right away. Now, we had step one was elaborate, but it's extremely foundational, and it's really important to pay attention to the strategy that you're following. But collecting this telemetry has also been easier. Without collecting, we don't have visibility. So let's talk about this a little bit. Now you can always send logs via the Amazon CloudWatch agent to CloudWatch, and then all kinds of metrics, Stats, Prometheus, CMF, also via the CloudWatch agent to Amazon CloudWatch. And with our recent launch of the new Amazon CloudWatch agent, you can now also send OTel with the same agent to Amazon CloudWatch and AWS X-Ray. And this is really helping us make telemetry collection easier, have a simpler architecture where one agent collects all telemetry. And of course, you can do this on AWS and on-premise with the systems manager, as well as you can sort of continually sort of simplify the experience such that it's as easy as one step for you. So we'll continue to do that. Now, the last three sort of steps are pivotal, and this is where all of the telemetry that you've instrumented and collected really comes into action. So I'm going to invite Rodrigue to switch to a demo and show us all this telemetry in action.
Thank you, Surbi. Hi, everyone. My name is Rodrigue. So we're going to do a demo. Before I open my computer to show you the demo, I'm going to ask you to do something for me. Can you take your phones out and scan this QR code? So this is an application that we built for this demo today. So what you will get here, you select a color in the demo, you click on it, you will have a haiku. For those who don't know, haiku is a Japanese-style poetry. It doesn't rhyme, and it's based out of the color that you will pick. So we use a little bit of Gen AI to generate this, and the goal for this demo is to understand how this application works, and then if there is an error, we'll try to find it. All right, so the QR code is still there, but I'm going to show you the architecture behind it. If you click enough on the colors, you will see a little animation. I think that would be nice. All right, so you have the application is an Amplify app, so it's deployed with CloudFront. It goes through a load balancer. So when you click on a color, we actually request to generate a haiku. So this goes through an ECS service. The ECS service is really, the architecture is decoupled, so we send a message to a SNS topic. The SNS topics on queues to an SQS. So that's pretty standard architecture to really decouple and scale on AWS. And then all the messages are processed by Lambda to generate messages with Amazon Bedrock, our new service for generative AI and large language models. And when we have the messages, we store them in DynamoDB. And to display them, we have another service that just does that. Goes to DynamoDB, fetch the messages in an optimized way. All right, so now we will dive into the console. But last but not least, the web application is instrumented with CloudWatch Real User Monitoring to understand the front-end part of the application. All right, so let me switch to the demo. All right, so I have here a dashboard, and then that will be really the anchor point for this demo. Can you lift your thumb if at the back you're able to see the dashboard correctly? Awesome, thank you. All right, so here I have in this widget, so sometimes you land into dashboards and you don't understand, okay, I have metrics here, I don't understand why this is happening. So really a best practice with dashboards is try to explain, like think about the users and then work backwards from that. What is the dashboards? What is its purpose? Obviously, there is no perfect, but try to give as much context as possible. So here, there's a link to the application, and then we have 4 dimensions really to understand the application. So for me, my goal with the application is that everyone gets a haiku. When you click on a color, my metric is making sure that you have a text generated for you. And then I want the application to be available. And I will do that through CloudWatch RUM, synthetics, and custom metrics. We're going to dive a little bit into that. And I want the application to be fast. Like if you're clicking and waiting on the color to be generated for a long time, maybe you would just do something else. And for Bedrock, I want to be sure that I am not throttled. The API responds all the time. So with that, I have a couple of alarms here. So you can see on the top right here, 4 alarms that really matches those goals, right? So what should wake me up at night is those alarms. I don't want to be woken up because ECS CPU is at 100%. Maybe it's not that important. But those metrics that are super high level help me understand that we are meeting the business objective of the applications. So here, for example, have high latency on the APIs. This is a capabilities on CloudWatch called composite alarm. So sometimes you have multiple alarms, but you want to be able to aggregate them and then have visibility into the results. So if I go to this to the detail page, you will see here that I have 2 child alarms for the post API, for the get API, and then if one of them triggers, then I will be called. So this helps reduce the noise and have high level visibility, but still able to dive into the details. So let me go back to my dashboard. So here you can see also successful haiku generation. So this is a custom metric from the application that I have on CloudWatch, on which I have alarms as well. But this is important for me, and I want to track it. So let me show you how this was done, and this is through CloudWatch metrics filter. So this is a powerful capability. If you have an application that is old, you don't even have access to the code, or you don't have developer cycles to go back and do instrumentation, this is something you can do, and I will show you. So here on the log group, so by the way, you can see the log class now in your console. You can see standard, and then you can switch that to the lower class as well and save costs. But you can see the metrics tab and the filters. So let me click into it, and you can see those filters. So my logs are structured with JSON, and I'm able to parse it with a JSON expression. And I say, if there is a Bedrock invoke error message, capture that, create a metric for me, a custom metric in a custom namespace, and you can do alarms on it. And then you can also understand historically how the application behaves, and then improve later. So this is the successful text generations as well. So this is an example of how you can leverage metrics from your application. Sometimes have rich logs, rich information, you can capture that. And this supports regex and then JSON navigation path, so you can create attributes and additional dimensions through those to those metrics. All right, let me close this, and let's navigate. So I can see there are some bumps. Thank you for testing the application. And there are some errors as well. But so this is, so you can see that, okay, there was a spike for the request that you just did. What I'm interested to see here is the number of total requests, the success of those requests, and the number of failures, like 4xx errors, 5xx errors. So this is pretty standard. All right, and then I have an end user monitoring. So really at the top of my dashboard is like really high level information to understand the state of the application from a business standpoint. But I want to be able to dive into the details, understand what is the users experiencing. Sometimes what we do is we will have applications that are super monitored on the back end, and we forget there is a front end, and between front end and back end, there is network. There is a lot of things that can happen. And then we want to be able to monitor that as well. So I'm going to open the CloudWatch RUM console. So real user monitoring allows you to have those insights into how the application is behaving. So here I can see If I open this, the locations, you can see users users from the United States. That's 95% of the sessions because we are here today. I live in Paris, and then this is when I was testing the application. So you can see that as well. You can see what the users are experiencing. So who's using Google Chrome? Show of hands. Awesome. And who is using Safari? Okay, let's see if that's true. So we have browsers and devices, so you can see the distribution really live right now with what you saw. So you can see half of them is Safari, because I think this goes back in time. So if I take like an hour, you will see that Google Chrome is getting more popular. And you can see the number of sessions per browser. You can dive into the errors. There's a lot of data here. There's a lot to unpack from that. But this gives you really an indication of how the user is experiencing. So sometimes you will see my goal is like 300 milliseconds of latency on the backend, but the users is actually 700 milliseconds. So this can be different. There is a word in between backend and frontend, and it's important to measure that. All right, and then some things that is important, and then I think one of my favorite service is synthetic canaries. So this allows you to continuously test applications, not only frontend. You can test APIs. You can test applications that live in the VPC. Essentially, what you do is with that is that you make sure that your users are not calling you because your application is not working. You would know this is a friendly user that tests your applications for you. And something that is really interesting, you have all those steps executed. So this is a managed Selenium or Puppeteer running and managed by us. You can have screenshots. So if I click on the screenshots, you can see the application, what the test was doing, all the different pages, and then the IQ generations. So if there is an error, not only you know, but you see what the user was experiencing. So this is really powerful. So if you have front-end application that you really want to see how it behaves, CloudWatch canaries, synthetic canaries can help you with that. All right. So moving down to those up to more metrics is DynamoDB. So I want to understand in my application what is successful. I use DynamoDB as a data store. And DynamoDB performance is actually related to how you shard it. Like if you shard it well, it's well balanced, you will have great performance. If you don't, then the performance will suffer a little bit. So here I have contributor insights. So this is something that can help you slice and dice top contributors, like in logs or with DynamoDB integration. So here I can see that the most requested color was cyan. That was before. But today, I think I saw that people love deep purple here. So that's good. I understand what is the popularity of the colors, and I can make decision. Okay, maybe deep purple this color is not performing well. Maybe I will remove it and do something else. So this is an example, but you can have top contributors and see, for example, if you have an operational event, you can see who's impacted. So this is really, really helpful. And what I want to see as well is the number of canaries that fail. This is really important for me, so I will bring it on top. You can see this gray band for synthetic canaries duration. So when I launch the synthetic canaries test, I want to track the duration. It doesn't matter too much, but I want to see if the duration changes over time, if I'm slowly increasing. Sometimes you have some errors that are silent, like latency increases. Like you can gain latency 30 milliseconds every week, and after a month, you will see that the application is degraded. With CloudWatch anomaly detection that you can turn on metrics, you can close a band and see if there is something that deviates from that. So this is really powerful and help you have this to catch those silent errors. So let's dive into the application status a little bit. So with that, we talked about tracing, and something that is really helpful with tracing is the service map. So here you can see if you remember the application, the architecture I show, let's actually open the CloudWatch service map. So you can see that if you remember the application I showed earlier, there was a ECS services and Lambda functions and all of that. So you can see that as a map, so you don't have to be 10 years in the company to understand what the application is doing. You have a map visually that represents that. So you can see ECS Fargate services, you can see DynamoDB. So let's actually see there's a bit of errors on Lambda. Let's actually view the traces. So you have the list of traces here and a bunch of errors. Let me open one. So let's start with a happy situation first. And okay, there's a lot of errors. Let me take the happy path. So here you have something that we launched last year is trace linking. So you will be able to see in a decoupled architecture. For example, I have an ECS service that enqueues to SNS. SNS send the message to SQS. By the way, there is no instrumentation on SNS and SQS. This is just an API toggle or turn on active tracing, and then you have this visibility into SNS and SQS. You also have a link to when the Lambda was invoked and then the other part of the transaction. So you can see the entire journey, and then you can see Bedrock and DynamoDB. So you have those link trace. You can see those are different transactions. Something that I really like is the queue time. So you can actually see how much time a message has spent in the queue before it was processed. So that allows you to do some optimizations, maybe optimize concurrency on Lambda, and then have some more scaling on your applications. You also get logs for this transaction, for all the nodes of the transaction, so you get what happened. So here you can see that the color was red, orange, and then this, everything worked great. But we saw that there are some errors as well. So if we go back to the traces list, we saw that there are some errors. So something happened here. I think this was a timeout, maybe. So there was a fault in the Lambda function. So we'll understand that later. All right, so I have those traces maps and widgets to understand, to have this quick links into the trace. There's something interesting, like you can turn on the metrics or the icons, the service icons, and with the metrics, you can see with the tracing data, the request per second for each node. So I can see that this service is quite popular, and then you have like 53 requests per minute, and then the average latency by default. So diving into from the business metrics to infrastructure metrics, so you can see, so we are on ECS. Something that we do a lot more right now is providing default dashboarding and insights automatically for customers. So I don't necessarily want to have a super busy dashboard. I just have some headlights. I want to understand how many tasks are running at this application. And if I want to dive deeper, I can go into CloudWatch Container Insights and then have that visibility. So this is ECS Container Insights. I can select a cluster, and then you will see all the services that are running. If you click into it, you have metrics on CPU, memory, and network. And to enable that, this is just an API switch to have that visibility into ECS Container Insights. All right, so let me go back to the dashboard. I have a load balancer as well. Again, same thing. There is a pre-built dashboard to understand load balancers, metrics and capabilities, so you can see all those metrics in the dashboard with all the ALB's data. But I want to pull like the ALB requests and 5xx errors just to understand how this works. I have queues and topics, as you saw, SNS and SQS. There's a lot of metrics. And here I can see that I have a queue, and then something that is actually a best practice is if you have a queue, you should have a dead letter queue. If you process a message a lot of times and it fails, you should maybe stop processing it. You discard it into a dead letter queue, and then you investigate later. So here I can see that my DL queue is has a lot of messages. So maybe there is something wrong happening. We saw that Lambda had some issues. So maybe this is linked to this. So something I want to do as well is to understand the logs out of this. So let me go back to Logs Insights. So if I open CloudWatch Logs Insights, so Logs Insights is how you query your logs that are sitting in CloudWatch. I have here a query that I have built for my service. All right, so let me take my application logs and then run a query. So here you have all the logs. So you can see that there were some transaction, and this is the test that you guys did. You can see that here. You have those logs showing here, but there's a lot of infos. Every application has a different logging style. Something you can do is use the new pattern detection. So here we will group the messages into pattern with the token. So you can see some stars here. You can inspect and see the log samples, the token values, really give you a high-level overview of what is happening on your logs. So you can understand the patterns. And if you have a lot of patterns that are not useful, you can discard it and then lower your costs on logs, for example. So those are Go applications, and I know in Go there is panic if there is something wrong. So let me actually search for panic, and let me take maybe a little bit back in time. So let me make sure that I have, okay, all the, all right, so I can see, so let me search for panic. I can see that I have some panic messages. That's not good, but it's not, the ratio is like 2%. So I have some errors. At the end of the day, my business alarms are not triggering, so this is not maybe something critical. This is something I need to fix later. But if we want to dive into this, I can use the query generator and also ask filter panic messages and update the query. So here you will have the query updated if you don't know the CloudWatch syntax. So there is a filter on message so if you're not familiar with the exact syntax, you can use the query generator assistant. And then if you rerun the query, I will remove that filter. And then, yeah, panic is all about my messages. So you can see the event ratio change. And then this has been only filtered to that. So if I go back to the logs, I can see I actually have a lot of them. You have the log stream. So if I click on the log stream, I will be routed to the exact panic message, the entire stack trace, and I can ping my developers, hey, there is a message here. Here's the line code, maybe you should check. But let's continue and do, I want to understand if this happens a lot, so I will do livetail on it. So if you click on livetailing, let me remove this stream to make sure I capture all of those logs and apply the filters. So you can see in live everything that is happening. Let me highlight panic messages. So we'll go back. Let's wait a little bit and see if we have some, okay. So yeah, you can see some red dots here. So those are the messaging that contains the panic errors. So you can understand that, okay, this is actually happening live on my application. This is not limited to that. You can add some more. You can have different. So let me say, for example, invalid Yeah, so you can have more pattern matching, and then this will happen live as well. So you can understand what is happening. All right, so we have some issues in the app, although they're not critical, but this is something that we can investigate even further. We see that there is a message that there are messages that are failing because Lambda is dequeuing my queue and then putting back the message in the dead letter queue. All right, so again, you have Amazon SNS dashboards and SQS dashboards that are pre-built on the CloudWatch console. So if you go to dashboards, you have automatic dashboards, and you can select all those dashboards for the services you use. And so here I refer them in my dashboard, and I can use them if I want to. So this is one of the best practices you can have as well. So on Lambda, I have anomaly detection on the Lambda duration. So you can see here invocation and errors are quite a lot. So to dive into this, I will use CloudWatch Lambda Insights. And on Lambda Insights, you can see even more. So if I zoom into this, you will see invocation and errors pretty close. There are actually more errors than invocations. And this is not good. For every invocation, you can see the memory percentage, the CPU time, and the duration. So if I scroll down, I can see timeouts. So let's actually click into this view. So this is an integration with CloudWatch service map, so X-ray data. So this takes me back to a tracing, to a trace map of what happened in that transaction. So you can see here, there was a timeout, so task timeout after 5 seconds. So what I would do is I will actually see the Lambda timeout, and then let's fix it. Maybe this will solve the problem. So let me open the Lambda configuration and fix the timeout. So let me bump the memory. So you saw that the memory was at 80%. So let's give some more, maybe 256 and 10 seconds timeout. All right, so this is deployed. I will clear the live tail and try to see if I have some more errors coming. So let's continue a little bit with the other metrics. So you have DynamoDB errors, DynamoDB metrics. So for example, something that is really important to track is how DynamoDB latency is impacted. So here you can see with anomaly detection that it stays in the band, so it means that my DynamoDB query are optimized. For example, you can see query, put item, get item latency that are tracked with this. All right, so let's see if the live tail is still showing red messages. So let me close all of that. So this is still happening. All right, but okay. All right, so this was just an example to see how you can go really to the top of the funnel and then dive into really specific. You don't have to, this is an example, you don't have to put a lot of metrics in dashboards. Sometimes you open dashboards, there's a lot of metrics, you don't understand what they are. So take some time to explain the dashboards, think about the operator that will use those dashboards, and then provide as much information as possible. And then with capabilities to dive into the details. As we said, there is possibility to leverage automatic dashboarding, and then with release like Container Insights, you can have information into pods, services, workloads, namespaces into your EKS clusters with just turning on an add-on on EKS with infrastructure as code or in the CloudWatch console. All right, let me check this so here I can see that I start to have more success than errors. And I think the error was just that Lambda was timing out, and then this generated some errors. All right, so let's switch back to the slides. All right, so we have seen in the demo an example on how you can dive into application performance monitoring from the user's perspective from the business perspective down all the way down to infrastructure metrics. We have one more thing we wanted to talk about is out-of-the-box best practices alarms. Sometimes you want to set up alarm, let's say, on EC2 utilization. Is it 80% that you should do? Is it 60%? Sometimes you don't know. Like, you have to understand how the application works. And then with this, when you turn on alarm recommendations, we will give you not only explanations on all the metrics. So if you click on a metric, you will have explanation on the metric, what it does, what are the baselines that we see from an AWS perspective. We will give you an example baseline, and then you will be able to improve from that. So not only will provide metrics, recommendations, and baseline on how you can do that, but the best thing is you can generate CloudFormation or Terraform code for that alarm, so you can just put it in your CI/CD platforms. So you can take any alarm today, and then if you go on the console, you can have CloudFormation or Terraform code for that. So it's not one more thing, two more things. So we have also, who here has data sources, data that is residing outside of CloudWatch? Show of hands. All right, sometimes even on-prem. And with this recent launch, multi-data source querying, you can have on CloudWatch dashboards the possibility to query data on Amazon OpenSearch, on Prometheus, RDS. You can do that on-premise. And then you can have a dashboard that is not only CloudWatch data, but also other data sources. You can do alarms on that. You can create alarms out of a Prometheus server that is on-prem or OpenSearch logs. You can create alarms and visualize them all in the same place. And so that's a bonus. It's something that I think will simplify a lot of visibility into application that span across multiple environments. All right, so let's recap a little bit Example Corp journey. So as we said, we see consistently those 5 pillars. Obviously, all applications are not similar, and then sometimes you will invest a little bit more into some pillars and others. But the really important piece is instrumentation and collection of telemetry. As you see, we are making it more and more simple, and we give you more insights out of the box. So leverage that. And if you want to dive deeper into everything we said, capture those resources. We have a workshop. We have best practices guide where we talked about metrics, traces, and logs. We have an accelerator that is Terraform or CDK code to get started with AWS observability. And we have a certification to learn, a skill builders course to learn about AWS observability. Also, we will be at the booth. We have a kiosk in the expo, so you can come say hi. You can come and chat about your own experience and journey. If you have specific questions, we can take some time. I will be there this afternoon, so come say hi. We have some swags as well. And yeah, we have also related sessions. So if you want to dive deeper into logs, there is a session, I think, in MGM on logs. Tomorrow we have also workshops. So if you want to experience hands-on with an AWS environment provided, you can go to those workshops and get your hands dirty. So thank you for your time. We really appreciate spending this time with you. I hope it was useful for you. We will be either here or in the hallway if you want to have, if you have some questions. And something I will ask is to not forget to take some time and complete the session survey in the application. That's really important to us to see how we can do better. By the way, if you like the session, that's 5 stars. I'm saying that because someone said to me, hey, I gave you 1 star because I thought number 1 is the best. No. All right, thanks a lot, and thank you for your time.